Okay, let's see if we can play around with a couple limit of the Riemann sums. They seem to be the hardest, and for a good reason. So they can be kind of complicated. Um, let's start with 43. Now, what we're doing is actually finding the area under the curve of this function from 0 to 1. So let's predict our answer. That way, when I get done, I'll know if I'm right. The actual answer that I'd only use to check my work, because this answer comes from the limit of the sum when I use my 0 to 1 of 1 minus x squared dx. So the answer I'm predicting will be x minus x cubed over 3 from 0 to 1. If I plug in the 1, I get 1 minus 1 cubed over 3 minus, plug that in, you get a 0. So that is what's happening. 1 minus a third is 2/3. So that's the answer I want. Wish me luck. Here's what we're going to look at. First, draw your picture of what this looks like. Upside down parabola, shifted up 1. But I only want the area from 0 to 1. So I will mark this 0 to 1. Now, theoretically, we are drawing rectangles, but they're very, very thin. So I'm going to blow this up just to mark one rectangle. And pretend it's blown up so that an ant sees it this size. First of all, we have to decide how wide is this whole distance. That's delta x, is always b minus a, in this case 1 minus 0. That whole distance is a 1. Now, how many rectangles will I have? Well, there is one rectangle. Here is another rectangle. Here is another. And it keeps on going, but they're so small. My last rectangle is n. Because I just have they're actually so paper thin. Remember, they're paper thin rectangles. And then in between those, if I can do it, no, I can't. I don't have good writing. There's a whole bunch of them, okay? This is blown up. So if you think about these as being x's or k's, it's going to be like your first right end is x sub 1, x sub 2, x sub 3, all the way to x sub n. So how wide are each of these paper thin pieces? It's delta x divided by how many they're going to be, and there's going to be n. So each width is 1 over n. Because there's n pieces, the whole distance is 1. So the width of every one of these rectangles are 1 over n, 1 over n, 1 over n. The height of each rectangle goes up to the function. So arbitrarily, I'm picking this height. That height is technically f of x sub, I labeled that as what? Just label it as x sub 3. X sub 3. Okay, and now it's so small though. All right, that's the setup. My area is the limit as n goes to infinity, because that's how many areas I have to create, of the sum of all the areas. So I'll start with a k equals 1, and I'm going to n. I'm summing every single rectangle, even though they're paper thin. Okay? I need my area formula for this rectangle. Well, the area formula for the rectangle that I just talked about, let me color it in for you just to give you some reference. It was my third one. And of course, this is blown up. All right. The area of that rectangle is F. I'm going to put back to the normal color. F of x sub 3. That's my length times my width, because it's just a rectangle. And the width I told you was 1 divided by n. Now, when you think about what that x value is, I also labeled him as, did I not label him as, let me blow up those 3 rectangles for a minute so you can see what I'm talking about. Here's my axis. I'm blowing it up, and in reality, my microscopic, I'm going to say that this is a 1 over n distance, and it's actually, let's see, 1 over n. That one is 2 over n. That one is 3 over n. So if I used a k up here, if k is counting from 1 to n, then arbitrarily each of these are a k over, a 1, no, it was a k over n. Each of these is a k over n. When k is 1, I got 1 over n. When k is 2, I got 2 over n. When k is 3, all the way to the last one, when I get to the n, k is equal to the n, that's n over n, which, by the way, is 1, because that's how far I'm going. So why don't I call every x value, I'll call every x value a k. What am I doing? That's supposed to be an f. F of k over n, and every width is 1 over n. But I want all of them. So I need to do the sum of all of them from 1 to n. So I'm going to put this down here. F of k over n times 1 over n is the limit as n goes to infinity of my f of x was 1 minus x squared, I believe, right? So I'm going to write limit as n goes to infinity of the summation of k is 1 to n of my 1 minus my x is k over n, and I'm going to square it times the 1 over n equals to. All right, let's try to expand this. Limit as n goes to infinity of the summation of k is 1 to n of a 1. I'm going to 1 minus k over n. I'm gonna actually do the foiling it. 1 minus k over n times 1 minus k over n is a 1 times 1, which is 1. Minus k over n minus, that's minus 2k k over n plus k squared over n squared. All of that is times my 1 over n. Let's simplify again. Equals to the limit as n goes to infinity of the summation. K is 1 to n. Distribute this in. That gives me a 1 over n minus 2k over n squared plus k over n cubed. All right. So how's that looking? It's 3 separate summations. So let me do something on the side here. I'm looking at the summation as k is 1 to n of 1 over n. I'm also looking at minus, that was a 2, so I can put on the outside, summation. It's a terrible summation I did there. Summation as what k, no, I messed up. I mean, I'm not wrong. I just wrote a symbol wrong. I'm just doing the 3 summation parts is what I wanted to do here. So my first one was the summation as k goes from 1 to n of 1 over n. My next one was minus 2 summation k is 1 to n of k over n squared. And then my third one was a plus summation of k over n cubed. So if I recall, and I don't have any notes in front of me, this is just a constant. It's a 1 over n. It looks like this. 1 over 1 plus 1 over 2 plus 1 over 3 dot dot dot. Remember? So it's just, what happens is I have n things going on. So I think it all added up to 1. So that's just a constant. So the secret was n times 1 over n. That times that just gives me a 1. This one, I'm summing up k, and that part's a number. So k is a 1, so that looks like this. 1 over n squared plus 2 over n squared plus 3 over n squared. I'm going to rewrite this piece as a negative 2, pull out the n squared. Then I got the summation of k equals 1 to n of k. Then I have a plus, pull out the 1 over n cubed, summation k is 1 to n of a k again. Guess so. So now I'm looking at, when I'm summing up k, that turned into, if I recall, let me go minus 2 over n squared. That turned into, if I remember what I did, so I'm trying to remember my notes. When I was equal to 1 to n of I, that the equivalent was n times n plus 2 over 2. I think that's what that was. And then if it was a constant and it was a summation of I equals 1 times 1 to n of some constant, then I end up getting that times the constant. So it's Cn. I think I may have done the other one wrong over here. So let me look. Yeah, I did this wrong. Let me hide the evidence. It's not a 1. It is an n because that was an n times 1 over n. That is a 1. I was right. I'm okay. And then that's not a k. That's supposed to have been a k squared here. K squared. So now I have to remember what was the summation rule of I is 1 to n of I squared. That's something divided by 6. I'm trying to remember what it was. Got to think about it. It was the same as the n times n plus 1, 2n plus 1. Okay, that's what it was. So over here, I got to change this to, what was I doing, Matt? This one here. This one became there's my 2 over n squared. K was my n times n plus 1 over 2 plus 1 over n cubed times n plus 1 times 2n plus 1 over 6. So I did all that work because, believe it or not, that's what goes here. To remove the summations, I now have equals to the limit as n goes to infinity of a 1 of a, let's see, can I cancel? I could simplify the 2 for sure. I could cancel out one of the n's, and so now I have an n plus 1 over n. So I'll do that. Minus, what did I say it was? I already forgot. N plus 1 over n minus n plus 1 over n. Let's see, this side, I can cancel out one of the n's, making that the square. And that's about it. So it's n plus 1, 2n plus 1 over 6n squared. Will I remember that? Was it plus? That was a plus. And n plus 1 times 2n plus 1 over 6n squared. Okay. Whew. This might be the only one I'm going to do with you guys. It's a lot of work. Limit as n goes to infinity. If it's wrong, I'm going to cry. Break this up into 1 minus n over n minus 1 over n plus, let me distribute that on the top. That's 2n squared plus the outside. n, 2n, that's 3n, plus 3n, plus 1. Still, each of those are over 6n squared. Over 6n squared, over 6n squared, 6n squared. I can clean it up one more time. I know some of you are already going to start canceling out n's. That gives me a 1 minus a 1 minus a 1 over n plus 2 over 6 and the n squared. Well, those cancel, leaving a 1/3. This gives me a half, and one of the top n cancels, leaving 1 over 2n, I think. Yeah. And this one stays 1 over 6n squared. Now, what's happening? As n goes to infinity, 1 stays a 1, but 1 minus 1 is 0. So that goes away. The limit as n goes to infinity of this one goes to 0, remember? 1 divided by a million. 1 pizza divided by a million friends, you get nothing. That goes to 0. Now I'm still left with, okay, a constant of a 2/3. This is 1 over 2 times infinity. That should go to 0. This should go to 0. So if I'm lucky, my area was equal to 2/3. Are we feeling lucky? Holy cow. Ooh, call me surprised. Okay. I'm going to leave that picture there for you. Wow, that was so much fun. And it only took me 20 minutes. Of course, I was doing it slow, and I made a couple errors, and I had to go back and erase. But that's the concept. I don't know if I want to take my chances and do another one. I did that really slow, so you should be able to follow what we do each time. But let's just pick. Let me go to the next page. Well, let me copy those problems here. Let's see. Edit. Touch this. No, I don't want to do that. I just want to do this. Copy that picture. Add a page. Let's try another one. Let me try with 2 x's in there. Let me try 47. Let's do f of x equals x plus x squared. Still from a lot of them are starting at 0 because it is the easiest. 0 to 1. What does that look like? Parabola. When x is 0, y is 0. When x is 1, y is 2. It's not an upside down, so it's going to have to open up. Probably something like that. So there's my area that I want to find. Reminding you that every microscopic rectangle, that when I'm counting them down, and I'll just go like this, my delta x is 1. Delta x is 1 minus 0 over how many will I have? N. So there's n number of slices. That means, and it goes a lot of them, whole bunch. Every rectangle will be a multiple of this width. So the first one would be 1 over n. The next place would be 2 over n, then 3 over n. So it's going to be some k over n on the right side of it. I'm just doing the right side of the rectangle. So my area should be the limit as n goes to infinity. Oh, you know what we should do? Let's find out what the answer is going to be if we get it right. Integrate x plus x squared dx from 0 to 1. That gives me x squared over 2 plus x cubed over 3 from 0 to 1. Obviously, when I put it in the 0, it goes away, so it's going to be 1/2 plus 1/3. And that's going to give me 5 over 6. Okay, let's continue here. Limit as n goes to infinity of the sum, as those k's are numbering those rectangles from 1 to n, of my f of x. But that x, remember, x is always some multiple of k over n. So k over n plus k over n all squared times the thickness of each, which was 1 over n. Okay. Area equals to the limit as n goes to infinity. Let me try to clean it up a bit. N is 1. K is 1 to n. If I square that, that gives me the k over n plus k squared over n squared. All of this times 1 over n. Yeah, that's what I should have made sure I say that. Okay, that's how accidents happen. Is the limit as n goes to infinity of the summation. K is 1 to n. Distribute that width inside, so that's k over n squared plus, what was I going to say before? It was k squared over n cubed. Okay, I can now keep going and say limit as n goes to infinity. Write those as two separate limits. It's the sum, I said separate limits, but I meant summations. K is 1 to n of k over n squared. And this is plus the summation. K is 1 to n of, and noticing I said n cubed. Where is it? I said k squared over n cubed. But it looks like I wrote n squared. So I have that could cause problem because I'm thinking n cubed, then I wrote I would write n squared. That would cause a big issue. All right. Okay, I have two summations. Okay, let me write it out. To get everything out of the summation equals the limit as n goes to infinity. Get everything out of the summation for k is 1 to n. That is not a k. So if I leave the k, that's 1 over n squared. Plus summation k is 1 to n. If I leave the k squared, that leaves me a 1 over n cubed. Okay, now that, one big limit. Now, I want to remove those summations. So we have to know the rules. And I know you all remember those rules. That the summation as k goes from 1 to n of k, which would mean 1 plus 2 plus 3 plus 4, dot, 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 forever and ever and ever, can be rewritten as n times n plus 1 over 2. Whatever n I'm going to, that's what it's going to be, the answer. And then the other one was summation k is 1 to n of k squared. That means 1 squared plus 2 squared plus 3 squared. That is n times n plus 1 times 2n plus 1 over 6. So over here I'm going to write, I got my 1 over n squared times n plus 1 over 2. Plus, I have my 1 over n squared times n plus 1 times 2n plus 1 all over 6. And I no longer have the summation symbols. Equals to the limit n goes to infinity of, well, it looks to me like that's an n squared plus n on top. N squared plus n on top, and the bottom is 2n squared. Plus, if I distribute the 2n plus 1 and n plus 1, that would be 2n squared plus 3n plus the 1. Now multiply it by the n. That turns into a 2n cubed plus 3n squared plus n. Yeah, 2n squared becomes 2n cubed, yeah, over 6n squared. I haven't done the limit yet, but n's going to infinity. So to make it simple, I will break those into fractions. N squared over 2n squared plus n over 2n squared plus 2n cubed. What's supposed to be it? And did I do it again? It's supposed to be n cubed in the bottom. I even see it, but then I wrote a cube. Man, that's gonna hurt me. You're probably already yelling at me. 2n cubed over 6n cubed plus 3n squared over 6n cubed plus n over 6n cubed. Okay, so remember that stuff we were doing? If you, if you have more n's in the bottom than the top, it goes to 0. Because look what that is n squared, that cancels it out. That leaves a half. This one has an n squared in the bottom, so when I cancel it out, it actually just leaves an n. That's the same thing as saying 1 pizza divided by 2 times infinity people. Since there's more n's on the bottom, this thing goes to 0. So it's basically gone. This one, the n cubes cancel, leaving a 1/3. This one has an extra n in the bottom. This has an extra n's in the bottom because that leaves 1 over n squared. So this goes to 0. This goes to 0. So I'm left with 3 plus 2 is 5 over 6 is my area. Well, it was my answer. It's been so long. 5 over 6. Da-da. Okay. Thank you for flying with Cartwright. This is an extra video to go over the whole process of summation. It's ugly. It's hard. Our book does not do a great job with it. Okay. Bye. I'll send this out to study for your test.